Hey everyone, thanks for joining us for a talk today. We're going to be talking about hands-on with GraphQL. My name is Sai Ekbote. I'm a software engineer at solo.io.
Hey, I'm Keith Babo. I'm a product manager here at solo.io. So as I mentioned, exciting talk. We're going to get super hands-on in today's session. We'll kick it off. Sai's going to cover how we integrate with upstream discovery and function discovery services in Gloo Edge to automatically generate GraphQL APIs. Then we'll start talking about getting into a little bit more of the details and the plumbing of how you set up resolvers to connect your GraphQL schemas to your upstream data sources and get data into those schemas. Then Sai is going to talk about as you scale GraphQL, you start to have many GraphQL APIs and you want to create a unified graph, how you can use stitching to actually create that federated graph. Then we're going to show the GraphQL UI. There's a couple of cool demos mixed in there. And then we'll just talk about the next steps and how you can get hands-on with this yourself. So before we get started, I just want to note we have so much great content in this talk that we don't have time to cover a lot of background. So if this is the first talk on GraphQL you're seeing at SoloCon, we really recommend that you also check out these talks here. The talk that Sai and I gave, which on introducing GraphQL, talks about background of GraphQL and what Solo's position is and what we're doing there. Then Kevin and Adam get into the details of securing GraphQL and some of the really deep level plumbing, really cool talk there. And then there's a workshop. So all of those things are great ways to get up to speed and how you can get hands-on in addition to watching this talk. So that out of the way, Sai, you want to talk about Schema Discovery?
Sure, yeah, sounds good, Keith. Thanks for that excellent intro. I did want to mention that this will be more of a 200 level course. The introduction to GraphQL in Gloo Edge and Gloo Mesh talk that we gave earlier at SoloCon was more of a 100 level course. So if you're not familiar with a lot of the GraphQL concepts, I'd highly recommend watching that first and then coming to this talk. So one of the main tenets of GraphQL is the fact that it's a strongly typed API protocol. It's a way of being able to communicate with your upstreams or multiple upstreams at once while knowing exactly what data you're going to be sending and what sort of responses you're going to be receiving back. So how do we exactly generate those GraphQL schemas, those GraphQL types from our existing upstreams without touching application code? Because as an organization, you may have, REST upstreams or REST services, gRPC services, SOAP services that exist in your cluster that might be legacy, might not have been touched in many years, that you want to modernize to GraphQL, but you don't want to touch the application code. Well, we've introduced a way called GraphQL Schema Discovery to basically modernize your applications to GraphQL without touching your application code and just doing this at an infrastructure layer or an API layer. So let's take an example. This is your current service layout in a Kubernetes cluster. You have a pet service, which is a REST API, a book service, which is a gRPC service, and a payment service, which by itself is also a REST service. Now, let's say you want to modernize these services to GraphQL. Well, your pet service currently exposes an open API spec. What is an open API spec? It's kind of like a type definition for the API. It exposes what endpoints exist in that service and what types those endpoints expect, as well as what responses they give back. And generally that's exposed as a big JSON such as this that has a list of paths and the inputs and outputs to those paths. So let's examine that open API spec a little closer. I'm going to take a look at this /pet/pet ID path right here, which has a get verb action. We translate this to a GraphQL query type and use the operation ID as the field name in GraphQL. The OpenAPI spec also provides us the parameters that the endpoint expects, so we can convert those parameters to the parameters that the GraphQL field expects. So for this example, we have the pet ID parameter in the OpenAPI spec, and we convert that to the ID input argument in the GraphQL spec. And you can see that the GraphQL output type is a pet output type. But how do we know exactly what that pet type consists of? Well, the OpenAPI spec also provides that information in the schema section. So if we scroll down a little bit in the OpenAPI spec, we see that there are responses, and a 200 response will provide back a pet type. So when we go down even further in the OpenAPI spec, we see that there's a schema section, and the pet type is enumerated out here with all of its specific properties that the upstream is going to serve back to you. So you have the ID, category, name, and status of the pet. And so it's almost a one-to-one correlation between OpenAPI spec types and GraphQL types. So we have a strongly typed system here where we can convert types from OpenAPI spec types to GraphQL types. And therefore, we're able to automatically convert and discover your OpenAPI spec and create GraphQL schemas from that OpenAPI spec. So now your pet service is essentially exposed as a GraphQL service to your clients. So your clients can run GraphQL queries on your pet service and get back GraphQL responses without ever touching a line of application code. Similarly, we can do the same thing for the book service, which is a gRPC service. Well, gRPC also has a similar specification called protocol buffers. And protocol buffers are essentially just another way of specifying the types that a service exposes. In this case, we have messages, which are essentially going to translate directly into GraphQL types. And we also have services, which state the actual remote procedure calls that you can make on that gRPC service. So we are going to generate GraphQL query types or GraphQL query fields from the protobuf services. So there's a one-to-one correlation here as well, where we create a getBook field in GraphQL from the getBook method in the book service in the protobuf. And we can also translate the inputs and the outputs of the getBook service or the getBook method to GraphQL types, because those are also enumerated in the protobuf definition. So here we create an input type in GraphQL called getBookRequest and an output type called book. So once again, now we've exposed two different services, each which are running a different API protocol, gRPC and REST respectively. And now both of them are unified through this GraphQL API protocol. So now that we've gone and converted individual services to GraphQL APIs, I want to zoom out a little bit, and I want to emphasize the fact that this is a layer above our application code. And so application developers don't have to worry about making any switch to the GraphQL spec or implementing a GraphQL server within their application. They just have to worry about maintaining their service definitions, and GraphQL Discovery will take care of the rest. So now that we've gone over what GraphQL Discovery does, or the schema auto generation does at a high level, we can make things more concrete by talking about how we can actually enable schema discovery today on our services or upstreams. So Gloo supports two modes of discovery. The first, which is allow list. When using allow list mode, we turn on discovery for specific services manually by labeling those services with this function discovery enabled label. So essentially what's happening in your cluster is we're going to label this payments or book service with the function discovery enabled label, and Gloo is going to go and basically look for the service definition, the gRPC definition in this case, and turn it into a GraphQL schema. And secondly, we allow for block list mode, which creates GraphQL schemas for all supported services unless explicitly disabled, which we can do with this function discovery disabled label. So in this case, we've gone and labeled our payment service with that disabled label, and GraphQL Schema Discovery will explicitly ignore that service while discovering the rest of our services in our cluster. So this just supports two different sort of workflows for enabling schema discovery for our services in our cluster currently. So now I'm going to hand the reins to Keith to talk about how exactly we wire up our GraphQL schemas to fetch data given a GraphQL request from our current upstreams without touching a line of application code.
Awesome. Thanks, Sai. All right. So Sai just did a great job of describing how integrating with upstream discovery can automatically generate GraphQL APIs. So that's taking what we might call a resource-first approach. For every upstream resource or API that I want to generate or that I want to have GraphQL for, I'm generating a GraphQL API from that. Another mode of operation is to go in the other direction and to start with the schema first. And when we start with the schema first, we're designing a schema, maybe with the front-end data model needs in mind, but then how do I connect it? This isn't discovered and automatically generated from anymore. I still need to connect the schema definition to my upstream APIs that are going to serve that data. And that exists via a piece of functionality called resolvers. So on the left here, I have a schema definition that's going to satisfy maybe a homepage for a bookstore where I have a card layout where I'm going to serve various products with details. And that data comes from many upstream data sources. So it's not a single upstream data source that I'm fetching it from, but multiple, and they're sort of related. There's foreign key relationships between them. How that works when we actually look at configuration is really two parts to it. The first is that when I need to supply data inside of my GraphQL schema, whether that's at the top here in the query definition, so that's the entry point for all clients that are invoking GraphQL operations, or I need to override specific fields and the data handling for specific fields in my schema definition, I'm using an @resolve annotation that references a name. And that name is then included as part of a resolver configuration. Both the schema definition and the resolver configuration are both part of the same custom resource that you apply in your environment to get a GraphQL API. So there's a hands-on talk. Let's get a level deeper here, and then deeper still when we're talking about this to really make sure that you're armed with the information you need. So at a really high level, the REST resolver configuration boils down to three parts. First, the request portion. So we receive a GraphQL operation. So we'll receive, like, let's say, a query. And then that query is going to be serviced by one or more upstream APIs. And the request portion of the resolver config controls when I request data from that upstream API, how am I formatting that request, that HTTP request? So that's one portion. The next portion is the response. So I've invoked that upstream API. Now I'm getting data back, and how am I fitting that data into my schema definition to satisfy that GraphQL request? And then finally, if you're familiar with Gloo Edge already, you're well aware of the concept of upstreams, and every resolver configuration has an upstream ref that connects it to an upstream API. So let's look at each of these in turn. So when we look at the request configuration, right at the top, we have the headers section, and there's two required aspects there. One is the method. This just tells us the HTTP method that you want to invoke, whether that's post, put, get, delete, patch, whatever you want to use there in your upstream API. And then also the path element. So basically, this could be a root path, it could be API v2, or whatever the path is of that upstream API. Then finally, we support any number of key value user-defined headers here. And these headers could be a static definition, like you see here, my header 123. We can pull data out of the GraphQL request itself and seed it there. We can dynamically pull data from the headers of the GraphQL request. So a very flexible capability here that's going to allow you to give your upstream REST APIs the data that they need. Finally, rounding out the other options here, query parameters. So this is the bit that goes after the question mark in your URL. You can specify any number of key value pairs here. Again, these can be substituted with variables based on the context of the GraphQL request. And then finally, the body. The body is really only useful when you're doing, when you're passing a body of data in the request. So like a post or a put or a patch. For gets and deletes, you really won't use the body field. Now that we've talked about the request, let's talk about the response. So in the response, there's two key fields. The first is result root. And what does that mean? That means that I could be invoking an upstream REST API that just barfs a ton of data back at me, right? And I only need a very small subset of that. And this data could be very hierarchical in nature. Result root allows me to narrow down that response data to a specific object or field that I'm going to map into my GraphQL schema. Setters is sort of a corollary capability there that allows for transformation of that data you're getting back into the GraphQL schema. So if you have a field name in your schema that doesn't match the response data, you can use setters to rectify that and to map that data. We also have a very powerful expression language or transformation language that can be used to manipulate that data, like to concatenate fields or select out data within return data to set that as part of the GraphQL response. And then finally, upstream refs. Again, this is what you know and love from Edge today. If you have a gRPC or REST API, that gets wrapped or discovered into an upstream, and then we reference that from, that's how we get the coordinates to the API, essentially, in the GraphQL API. All right, so now that we know we're familiar with the syntax, let's walk through a quick example here of how this works. So if we're looking at a GraphQL query and someone comes with a request for products for home, again, that's our entry point to our GraphQL data model here. So we see that there's an @resolve there and it's returning a product, all right? And here is the actual definition of that configuration. So we know it's a GET, and we know that it's going up against this default product page upstream API, and it's passing this path. There's no other configuration here because we're actually able to take that response data and automatically map it into the product data type here in our GraphQL schema, because all of these fields match and the nature of the data just fits perfectly on its own. But there's a lot of other fields that aren't satisfied by this request. There's other REST APIs that we need to invoke. So how do we handle those? And that's with more resolvers. So here we can see for the author page, we need to go to the details API. And we can see here a substitution variable that's actually, we've already fetched the product details and the product ID. I can use that data in other resolvers as sort of a foreign key to correlate that data and grab related data all within one GraphQL API call. So we can see here also that we're narrowing down the response with the result route. We're getting a lot of data back from this details API. We're going to narrow that down just to the author. We're going to do the same for pages and for year. More advanced examples here, if we look at reviews, this is a list that comes back. And again, we see some of the automated data mapping that's already happening for you. We're querying an upstream REST API. It's giving us a sort of nested list. We're pulling out a list inside of that. And then we're automatically, the GraphQL runtime is automatically creating that list and populating it into the GraphQL schema because the reviewer and text fields automatically match the response data. In other cases, I'm getting a list back here in ratings, but for the ratings API, it's giving me a stringified map. So now I get to exercise some of that cool transformation logic to go into that string that's getting returned and create, basically store a key and value and parse that into the reviewer and num stars field. So really flexible transformation language there. All right, Sai, that's all I've got in terms of getting into the depths of resolver. And we didn't even touch all of it. There's mutations and data transformations and all kinds of other really cool things that we can do. But now I think we should turn our sights on how we create a unified graph and federate our subgraphs using schema stitching.
Yeah, Keith. And a unified graph is a really powerful concept because so far we've talked about individual graphs or individual services in the context of GraphQL, right? We're turning individual services, gRPC services, REST services into GraphQL schemas by themselves. But let's say we were to have 50 or 500 of these services in a cluster throughout your network architecture. You don't want to expose, 50 or 500 different GraphQL endpoints. You only want to expose one, maybe maximum a couple of GraphQL endpoints. Because otherwise it defeats the purpose of one of GraphQL's main benefits, which is that you can fetch data across different resources from a single query. So from a single GraphQL operation, you can essentially stitch together multiple GraphQL sources or upstreams without having to do any special chaining logic on the client side. All of that's sort of handled by the GraphQL server. So how exactly do we do that? And how do we accomplish this sort of schema stitching or GraphQL server stitching? In order to answer that question, I'm of course going to use an example. Here we have a Kubernetes cluster, which has three GraphQL services running in our cluster. So we have a user service, a review service, and a product service. These services are running in their own pods, their own separate applications, but they each are contributing to a unified data model. So you'll notice that each of these has a user type, some of them have a product type, and there's also a review type. So each of these types are actually part of a larger sort of gateway type or a stitch type when put together. So how do we sort of stitch these services together so that users can only issue one query and the Gloo will take care of the rest as far as issuing the respective queries to each of these services and stitching the response back? Well, let's first start off with what an individual query would look like to one of these services. Here we have a query to the user service, a get user with full name query. We're going to get the full name of this user, A Keith, and get it back as Abigail Keith. Similarly, for the product service, we issue a query for a product, and we issue for some product with an ID of 125, and we get back the name of the product, Narnia, great book, and the seller, who happens to be A Keith. Now, let's say we want to get the full name of this seller, this user, A Keith. Well, the product service won't be able to tell us that. In fact, if we were to go ahead and run that query on the product service, we'd get back null or an error from the product service. So if you remember, the user service does provide that full name information. And it also provides a query that allows us to get the full name for a user given the username. So we can give Gloo some hints saying, okay, I have the user type here. And if you give us this key of username, we can run a query on the user service to get back all the full user information from the user service, including the full name. And similarly with the product service, we can do the same thing. If you give us a product with a certain ID, we can get all the product information you might want from the product service, for example, the product name or the seller. So now we can run that same query against this product and user stitch service, which we stitch together with that YAML type merging configuration that I showed you in the slides previous. So now when we run that query, we see that the full name field is populated in the response because now we're stitching the schemas together and Gloo is taking care of making a call to the product service and then making a call to the user service for the full name of the seller for the product. Expanding this a little more, if you remember, we also have a review service. We can also stitch that into our sort of stitch schema. And we're going to call that the gateway schema, since this is essentially a gateway into our cluster, into our GraphQL cluster. So given the type merging configuration that we had in the previous slides, we can now create a gateway schema or a gateway API that's essentially a gateway into our three services running in our cluster. So this gateway schema encompasses all those three services partial types to create sort of these super types that essentially stitch all those subschemas together. So what does this mean? We can now run a query against this gateway schema that includes information and asks for information from each of our services while only creating one query from the client. And to really highlight this, I'm going to go ahead and add some color to this query to show exactly which of these services each part of the query is coming from. So we can see the full name is coming from the user service, the product and the seller is coming from the product service, and the reviews related fields are coming from the review service. So when we run this query against the stitched API or the gateway API, we get back a response, a stitched response from the gateway. And you can see that it includes data from each of our services in one succinct response. Once again, I'm going to add the color here to show that each of these fields are coming from different services, but are stitched together to form a coherent sort of response for our query. So now that I've shown you what that looks like conceptually, we can go ahead and look at a demo for what this actually looks like in our live running Kubernetes cluster. All right, so now I have a local environment running where I have a Kubernetes cluster running in Docker. So now I'm going to show you how we can use Gloo Edge to convert our existing applications to GraphQL applications without ever touching any application code. So in our cluster, we have two services that are currently running. We have a pet store service and we have a gRPC service. Each of these services are port forwarded to localhost 8081 and localhost 8082 respectively. So we can go ahead and inspect these services and use the curl tool on the REST service, for example, to look at the OpenAPI JSON endpoint for this service. So we get back a bunch of JSON that basically shows us what the OpenAPI spec for this service is, or we can go to the Swagger UI and we can explore this endpoint, and we can see that the Swagger UI shows us all the endpoints that this service exposes and that we can query as a user. Similarly, we can do the same thing with gRPC, but as you may know, gRPC uses protocol buffer definitions, so we're going to have to use a special tool called gRPC curl to list out the services that this gRPC pet store provides. So we see all these methods that the gRPC pet store provides, and this lines up pretty well with exactly the pet store proto that this gRPC service uses. So all the service definitions are right here, and those are the exact same ones that the gRPC service gave us right here. So now let's turn these services into GraphQL services. Normally, this would be a pretty big undertaking involving an entire team modernizing the application by implementing a GraphQL server in whatever language those applications are written in, as well as writing resolvers for each of the GraphQL fields. However, Gloo Edge makes this process super easy using Schema Discovery, as I talked about earlier in this talk. So let's go ahead and enable Schema Discovery for these services by labeling these services with this function discovery enabled label. And similarly, we're going to do this for the pet store gRPC service. And as we label these services, you're going to start to see that Discovery is going to discover the service definitions, the gRPC protobufs and the REST OpenAPI spec definitions, and convert those definitions into GraphQL schemas. So now we can actually see these GraphQL schema CRDs in our kind cluster. And we can go ahead and browse these schemas by looking at the resource definitions themselves. So we can see that for this particular GraphQL schema, which aligns with the pet store service, we can see that all of the pet store OpenAPI spec endpoints have been turned into GraphQL query fields. And similarly with the gRPC service, it's turned all the proto services that we see here into GraphQL types. So we have this GraphQL query type, and each of these service methods correspond to a query field, as well as the type definitions from the protobuf correspond to input and output types in the actual schema definition. So now we're going to create a virtual service to route traffic to our GraphQL schemas or backends. So we have a virtual service definition right here, and in that definition we specified two routes. Each of these routes routes traffic to a different GraphQL backend. One routes to the REST backend, and the other routes to the gRPC backend. And if we go ahead and apply this GraphQL virtual service, let that configure itself, we can now use the GraphQL playground to actually query these running GraphQL services. So let's go ahead and run a query. And you can see that this query is actually going and querying our GraphQL server in the gateway proxy. But I want to remind you that we haven't touched a line of application code. So what's happening here is that we are converting these queries into actual REST requests, sending it to the REST upstream, and the pet store upstream is going to give us back a JSON response, which then we're going to process and filter so that we get back the data that we actually want. So for example, we're only going to get the data that we asked for each of our queries. So now we're going to do the same thing for our gRPC backend. We're going to issue a query, this find pet by ID query, which comes from the protobuf definition right here, and issue that against our gRPC backend. And we can go ahead and query the gRPC backend the same as we did with our other sources. So now, what if I want to query that REST service from this gRPC endpoint? Well, I can't really do that because if I were to type in this get pet by ID query here, it's not going to recognize it. In fact, it doesn't even exist in the gRPC schema. And that's only because this was discovered from the gRPC service, so it obviously knows nothing about the REST service. This is where schema stitching comes in. So what we're going to do is create a gateway GraphQL service or gateway GraphQL schema, which is going to stitch these two sub-schemas together and allow us to query both of these subschemas from one single query. So all we've done is referenced each of the GraphQL subschemas in the subschemas section right here. And we can go ahead and apply that. So now that we've created this gateway GraphQL schema, we also have to hook it up to a virtual service. So let's do that right here. Comment this. And now we have this GraphQL gateway route, which uses the gateway GraphQL schema. And let's go ahead and apply this change to the GraphQL virtual service. And once we create that gateway GraphQL schema, we're going to see that Gloo automatically generates the GraphQL schema, the super schema, that's going to include both the gRPC pet store and the REST pet store GraphQL schemas in it. And we're going to copy that GraphQL schema. You can see that all the types from the REST service as well as the gRPC service are in this query type. So now let's query this gateway schema and see this in action. So right now we have a query here, which does the get pet by ID from the REST service, as well as the find pet by ID from the gRPC service. And these two queries are running independent of each other in the backend and querying each of their respective services. And then Gloo is bringing back the responses and stitching them together into one coherent response for the client. So your client doesn't have to worry about making a request to one service and then making a request to another service. Instead, the client just has to make one request, and Gloo will do the hard work of delegating that request to each of the backends and stitching the responses together to form a coherent response. And that's it for my demo for schema stitching.
That was an awesome demo, Sai. Really, really impressive to see that all come together. All right, so now let's switch gears here. And we've been doing a lot, looking at config, raw configuration, seeing a lot of stuff from the command line. There's a whole other angle to our GraphQL support, which is what we've added to the Edge UI. So what better way, since this is a hands-on talk, and we've seen enough slides for today, I think, I'm going to go right into another demo where we see the GraphQL UI in action. All right, here we are in the Edge UI, which you may already be familiar with. But one thing you probably haven't seen is this new nav item here for APIs in the top menu. When I click on that, I get a list of all the GraphQL APIs I've deployed. This functions very much like an API registry or schema registry for GraphQL, and that now I can go in as a consumer of these APIs. I can go click on, for example, the pet store GraphQL API that Sai was discussing earlier, which was automatically generated. I can come in and see all the queries that are available on this API, all the various types. So if I want to look at like the pet type, for example, I can see the fields available on a pet type, and even the mutations are listed here as well. I also have details on the upstreams that I'm integrating with. So I can click on the pet store and get details on that upstream API that GraphQL is sitting in front of. But the main thing I wanted to show from a hands-on perspective in this UI is the ability to actually create new GraphQL APIs as well. So let's follow that workflow. So I'll click on Create API, and then we'll call this one My Book Info. And this is going to be based off the book info example that we looked at earlier. Go ahead and select the schema definition. So I'm not supplying any other configuration other than the original schema definition that I want to use. So I'll say Create API. And if we go and look at the underlying config, I can see that there's a CRD here. It has the schema definition in it, but nothing else, no resolvers. So my job now is to hook up, to make this a live API, to hook up all those resolver configurations. So let's go ahead and get started with the top level query, the entry point for our GraphQL API, which is products for home. I'll go ahead and define a resolver. Here I want to specify this is a REST API type. I could also choose gRPC if I had that available. And then I'll get a list of REST APIs in my environment. In this case, we're going to go and click on product page, which is the upstream for the top level details I want. And now I get prompted for the resolver config, which is pretty straightforward. I'm just going to provide the method and path. And then we are going to, that's all I need for this particular resolver. Next thing I'm going to do is, if you remember, some of the details in my graph were satisfied by one API, but there are actually like 4 different APIs that I wanted to mash together for this particular GraphQL schema. And so what I'm going to do is navigate down into product, and there's some individual fields here I need to define specific resolvers for. So like authors, pager, or author, pages, and year are all from the details API. So let's go ahead and define those as well. Again, this is a REST API. And now instead of product page, I'm going to details. And this is a get, and the path is slightly different. And we're going to actually, now that we've resolved that product detail, I'm going to use that to take the ID from that resolved parent and use that on the details API to get specific details for that book. Only other thing I want to specify here is I want to narrow this down just to the author field. And we're good to go. And I'm going to repeat this pattern. So I've just copied that config here. For pages, very similar thing. We're going to get that from the details API. And we'll go ahead and just update that. And then finally for year, same thing. Go into the details API and we'll specify year. All right. Last field I want to get in this before we actually show it live in action is a review field. So that's yet another API that's pulling data from. So we'll go ahead and go to reviews as the upstream, and we're changing the actual path here and what I'm getting back. And now I'm done. We can see here that the upstreams I'm talking to have automatically populated on this page. And the next thing I want to do is make sure I'm enabling introspection for this API. So let's go right back up, and we can see that that's disabled by default. So I'll go ahead and enable that. Now, what does that do? That provides a really useful feature here. If I want to come in as a developer, or even we were seeing before the catalog use case where someone else has created a GraphQL API and I'm just looking at the documentation, or maybe I want to try it out. So I'm going to come over here into the Explorer page, and we can see that I've got a live interactive Explorer that's available. All of the documentation from my schema definition is available here, so I can see that all listed if I need details in the various fields. And we also have the ability, let's call this a books query, and we can see that I have autocomplete for the various fields. So that's the query. I want products for home. And let's go ahead and pull the title, the author, number of pages, and year. And now I can run this query, and I get that data live back to me. So this is really exciting, not just from the standpoint of traditional API registry and schema registry use cases, but also as a development tool. So your dev teams can get up and running quickly, purely through the UI, creating new GraphQL APIs based on the upstream REST and gRPC APIs you've already deployed.
That was a great demo, Keith. Thank you for showing us the UI. Now, being the product manager for the GraphQL product, could you tell us a little bit about the next steps for GraphQL?
Yeah, for sure. So just going back to what we were talking about earlier, and Sai mentioned, if you haven't seen the other GraphQL talks or maybe haven't done the workshop, please go out and check that information. There's great individual content in all those talks that fill out the broader picture of the importance of GraphQL across Gloo Edge and Gloo Mesh and everything we're doing here at Solo. In addition to that, we're super happy to announce the beta of Gloo GraphQL here at SoloCon. So this is part of the Gloo Edge 1.11 release stream, and the beta is now available for everybody to get hands-on. We won't go into all the features. There was another talk that talked about all these features, but you can see here that's a lot of great stuff in the beta to get a hands-on with. So we want you to go out there, grab those bits, and let us know your feedback. Thanks very much, and we'll see you all in the next talk.